Hello guys, I am Harshith, currently studying at Sri Venkateswara College of Engineering of branch ISC 3rd sem. Today we are going to study about three main topics related to the subject data structures and applications. They are additional list operations, sparse matrices and doubly linked list. Let's come into the video. At, Firstly, additional list operations. The additional list operations have certain types. Sorting lists. Sorting list involves arranging the elements in a specific order, such as ascending or descending. It helps in organizing the data for easier analysis. Sorting methods: ascending order, descending order, alphabetical order, reverse order, and custom sorting. Ascending order, which means arranges the elements in increasing order from the smallest to the largest. Descending order arranges the elements in decreasing order from the largest to the smallest. Alphabetical order, sorting the elements based on their alphabetical order from A to Z. Reverse order reverses the order of the elements from the last element to the first. Custom sorting allows for sorting based on specific criteria such as sorting by date or by sorting custom defined order. And second one is merging list. List consolidation. Merging list involves combining two or more into a single list. This process is useful for consolidating data from multiple resources such as different departments or teams within an organization. Steps for merging lists. Identify the lists to be merged and ensure they have compatible data structures. Determine the criteria for merging the list, such as common fields or unique identifiers. Combine the lists by appending or concatenating them, ensuring data integrity and avoiding duplicates. Cleanse and transform the merged list as needed, such as removing redundant or irrelevant data. Validate the merged list to ensure accuracy and completeness. And the third one is splitting lists. Splitting lists involve dividing a single list into multiple lists based on a specific condition. It helps in organizing data into separate categories. Different splitting methods: by value, by length, by category, by data, and by frequency. By value, which means split the list based on the specific value. All elements with the same value will be grouped together. By length, split the list based on the length of the elements. Elements with similar lengths will be grouped together. By category, split the list based on predefined categories. Each element will be assigned to a specific category. By date, split the list based on dates. Elements within the specific date range will be grouped together. By frequency, split the list based on the frequency of occurrences. Elements with similar frequencies will be grouped together. And finding unique elements. Finding unique elements in a list involves identifying and extracting the elements that occur only once in the list. It helps in identifying distinct values. Methods for finding unique elements. Method: convert the list into a set to remove duplicate elements. Then convert the set back into a list to obtain the unique elements. Using a dictionary. Iterate through the list and use a dictionary to count the occurrences of each element. Extract the elements with a count of 1 to obtain the unique elements. Using list comprehension. Use list comprehension to create a new list that contains only the elements that occur once in the original list. Using the counter class. Import the counter class from the collection module. Use the counter class to count the occurrences of each element in the list. Extract the elements with a count of 1 to obtain the unique elements. And reversing the lists. Reversing a list involves changing the order of lists in a list such that the last element becomes the first and vice versa. This operation can be useful in various scenarios, allowing you to view the data from a different perspective. Process of reversing a list. To reverse a list, follow these steps, which are: start from the beginning of the list, swap the first element with the last element, move to the next element, and repeat step 2 until you reach the middle of the list. And the second topic of our video is sparse matrices. And what are sparse matrices? Sparse matrices are matrices that have a large number of zero elements compared to the total number of elements. Characteristics of sparse matrices. Sparse matrices are memory efficient as they only store the non-zero elements. Sparse matrices can be represented using different data structures such as linked lists, dictionaries, or compressed formats. Sparse matrices are commonly encountered in various fields such as scientific computing, machine learning, and network analysis. Applications of sparse matrices. Sparse matrices are used in solving systems of linear equations and performing matrix operations efficiently. In machine learning, sparse matrices are used to represent high dimensional data and perform dimensionality reduction techniques. Sparse matrices are utilized in network analysis to model relationships between nodes in a network. Representation of a sparse matrix. CSR, compressed sparse row format, or CSC, compressed sparse column matrix format. The compressed sparse row format is a commonly used method for representing sparse matrices. It stores the non-zero elements of the matrix along with their corresponding row and column indices. This format is efficient for matrices with a large number of rows and a small number of non-zero elements. Compressed sparse column format. The CSC format is similar to the CSR, compressed sparse row format, but it stores the non-zero elements along with their corresponding column and row indices. This format is efficient for matrices with a large number of columns and a small number of non-zero elements. Sparse matrix operations: addition, multiplication, and transposition. Addition. Sparse matrices can be added together by adding corresponding elements. Only non-zero elements are considered in the addition process. Multiplication. Sparse matrices can be multiplied using various algorithms such as the compressed sparse row or compressed sparse column formats. These algorithms efficiently handle the sparse nature of the matrices to reduce computational complexity. Transposition. The transposition of a sparse matrix involves swapping its row with its columns. This operation can be performed efficiently by reordering the non-zero elements based on their column indices. Applications of sparse matrices: network analysis, image processing, scientific computing. Network analysis. Sparse matrices are commonly used in network analysis to represent and analyze large-scale networks such as social networks, transportation networks, and computer networks. By leveraging the sparsity of these networks, efficient algorithms can be developed to compute various network properties such as centrality, measures, clustering coefficients, and community detection. Image processing. Image processing. Sparse matrices find applications in image processing tasks such as image denoising. In image compression, sparse matrices are used to represent images in a compressed form, reducing storage space and transmission bandwidth. In denoising, sparse matrices are utilized to remove noise from images while preserving important details and structures. Scientific computing. Sparse matrices play a crucial role in scientific computing, particularly in solving large systems of linear equations and eigenvalue problems. Many scientific simulations and computations involve sparse matrices, and efficient algorithms have been developed to exploit their sparsity for faster and more memory efficient computations. Applications include computational physics, computational biology, and computational chemistry. Advantages and disadvantages of sparse matrices. Advantages: reduced memory usage. Sparse matrices store only non-zero elements, resulting in significant memory savings compared to dense matrices. Efficient computation. Sparse matrices allow for more efficient computation due to the reduced number of operations required. Improved performance. Sparse matrices can lead to faster execution times for certain algorithms, especially when dealing with large data sets. Disadvantages: increased complexity. Sparse matrices require additional data structures and algorithms to efficiently store and manipulate the non-zero elements. Limited applicability. Sparse matrices are not suitable for all types of data and algorithms. They are most effective when the majority of non-elements are zero. Higher storage overhead. Sparse matrices can have higher storage overhead compared to dense matrices when the number of non-zero elements is relatively large. And the last topic of our video is doubly linked list. Doubly linked lists are the type of data structure that consist of a sequence of nodes where each node contains a value and two pointers, one pointing to the previous node and one pointing to the next node. Purpose in data structures is doubly linked lists are used to efficiently perform operations such as insertion, deletion, and traversal of elements in a data structure. They provide flexibility in accessing elements in both forward and backward directions. Similarities to single linked lists. Doubly linked lists share some similarities with singly linked lists. Both types of lists consist of nodes that contain a value and a pointer to the next node. They can be used to implement various data structures and algorithms. Differences from single linked lists. The main difference between double linked lists and single linked lists is that double linked lists have an additional pointer in each node, pointing to the previous node. This allows for efficient transversal traversal in both forward and backward directions. Nodes and pointers. In a double linked list, each node contains a value and two pointers, one pointing to the previous node and one pointing to the next node. These pointers are used to navigate through the list and perform various operations on the elements. Node structure of a node. In a double linked list, each node consists of three components: data, previous pointer, and the next pointer. Data. Data is the actual value or information stored in the node. Previous pointer. This pointer points to the previous node in the list. Next pointer. This pointer points to the next node in the list. Advantages of double linked lists: allows traversal in both directions, efficient insertion and deletion, allows transversal in both directions, which means the presence of previous and the next pointers in each node allows for easy traversal in both forward and backward directions. Efficient insertion and deletion. Insertion and deletion operations can be performed efficiently in a doubly linked list as compared to a single linked list. Disadvantages of double linked list: increased memory usage, which means the presence of an additional pointer in each node increases the memory usage of the double linked list as compared to a single linked list. Operations on double linked list: insertion and deletion, and traversal and searching. When coming to insertion, insertion is a process of adding a new node to the double linked list. There are three possible scenarios for insertion: insertion at the beginning, insertion at the end, insertion at the specific position. Insertion at the beginning, the new node becomes the new head of the list. Insertion at the end, the new node becomes the new tile of the list. Insertion of a specific position, the new node is inserted between two existing nodes. Deletion. Deletion is the process of removing a node from the double linked list. There are three possible scenarios for deletion: deletion of the head, deletion of the tile, deletion of a specific node. Deletion of the head, which means the head node is removed from the list. Deletion of the tile, which means the tile node is removed from the head, and deletion of the specific node, the node at the specific position is removed from the list. Traversal. Traversal is the process of visiting each node in a double linked list. There are two common methods for traversing a double linked list: forward traversal and reverse traversal. Forward traversal, which means start from the head and visit each node in the forward direction. Reverse traversal, start from the tail and visit each node in the reverse direction. Searching. Searching is the process of finding a specific node in the double linked list. To search for a node, we can start from either the head or the tail and traverse the list until the desired node is found. The time complexity of each operation on a double linked list is follows: insertion, deletion, traversal, searching. Insertion. For insertion at the beginning or end, 0 of n for insertion at the specific position. Deletion, O of 1 for deletion of the head or tail, O of n for deletion of the specific node. Traversal, O of n for both forward and reverse traversal, searching O of n in the worst case. Advantages of double linked list: efficient insertion and deletion, easy traversal in both directions, flexibility in implementing various data structures. Disadvantages of double linked lists are additional memory requirement, increased complexity. Advantages of double linked list: efficient insertion and deletion. Double linked lists allow for efficient insertion and deletion operations at both ends. This is because each node in the list contains two pointers, one pointing to the previous node and one pointing to the next node. Easy traversal in both directions. Another advantage of double linked list is that they allow for easy traversal in both directions. Each node in the list has a pointer to the previous node and a pointer to the next node. Flexibility in implementing various data structures. Double linked lists provide flexibility in implementing various data structures. For example, they can be used to implement stacks and queues efficiently. Disadvantages of double linked lists are additional memory requirement, increased complexity. Additional memory requirement. Each node in a double linked list requires extra memory to store two pointers, one for the previous node and one for the next node. Increased complexity. Implementing and maintaining a double linked list can be more complex compared to a single linked list. Applications of double linked list. Implementing stacks and queues, binary trees, browser history. Undo and redo functionality, and image sliders. Okay. Applications of double linked lists, implementing stacks and queues. Double linked lists can be used to implement both stacks and queues efficiently. In stacks, the top element is always at the head of the list and new elements are added and removed from the head. In queues, new elements are added at the tail and removed from the head, maintaining the first in, first out order. Binary trees. Doubly linked lists can be used to implement binary trees, where each node has reference to its left and the right child nodes. Browser history. Double linked lists can be used to implement browser history functionality. Each page visited is stored as a node in the double linked list with the previous and the next pointers representing the previous and the next pages. Undo and redo functionality. Doubly linked lists can be used to implement undo redo functionality in applications. Each action performed is stored as a node in the double linked list, allowing for easy undo and redo operations by traversing the list backward and forward. Image sliders. Double linked lists can be used to implement image sliders or carousels in web applications. Each image is stored as a node in the double linked list, allowing for easy navigation and smooth transitions between images. And it's been my representation or presentation about this topic, guys. Thank you one and all for watching my video. Thank you, guys.